Let's talk about how satellites actually go from one orbit to another orbit. Let's say that you have a satellite that's sitting at low Earth orbit, but you want to go up to geosynchronous orbit. You need some way of actually doing that. And there is a thing called a Hohmann transfer, which allows you to move from one orbit to another in an easy way. Hohmann transfers use what's called an elliptical orbit, which we've talked about, where one part of the orbit is close to the Earth and one part of the orbit is far away from the Earth. And you can basically use the property of an elliptical orbit to go from, say, a low Earth orbit to a high Earth orbit, or a geosynchronous orbit, if you will. And the way that you do that is you go from a circular orbit, and then you have to accelerate to an elliptical orbit. And then instead of falling back down towards the Earth, you accelerate a little bit more when you reach that apogee, and then you stay on the circular orbit. Now, the interesting thing is that you can do exactly the same maneuver, but to go from a high orbit to a low orbit. You start at a high orbit, say geosynchronous orbit, and then you decelerate, which puts you on an elliptical orbit back down towards Earth. And then once you get to where you want to be at perigee, you slow down again. And so instead of continuing on that elliptical orbit, you slow down and you stay at the circular orbit. If you had a geosynchronous satellite and you wanted to bring it down to low Earth orbit, you would do this type of a maneuver. You would do a Hohmann transfer. And we don't often do that near Earth. If we wanted to bring something from a higher altitude down to a lower altitude, most of the time that would be to deorbit the satellite. And so you would do the first part of the orbital maneuver. So you start off in a high circular orbit, you go into an elliptical orbit, and what you do is you have the perigee, so it's deep in the atmosphere. So the satellite comes into the atmosphere and then it burns up in the atmosphere. This diagram of circle, ellipse, circle is useful all over the place. So if you want to go to low Earth orbit to geosynchronous orbit, you use a Hohmann transfer, and the inner body is the Earth. If you want to go from Earth to Mars, it looks exactly the same. You have Earth's orbit around the sun, you have Mars's orbit around the sun, and you use a Hohmann transfer to go from the Earth to Mars. And you could do this with any planet to planet. You could go from Venus to Earth or Earth to Venus. You could go from Earth to Jupiter, Earth to Pluto, whatever you would like to do, you can use this Hohmann transfer. Interestingly, NASA has put out a little video here which actually shows how to get to Mars from Earth. And it shows exactly this Hohmann transfer. So you start off, the little satellite starts off at Earth, it goes on this elliptical orbit, and then once it gets to Mars, it accelerates up to Mars's speed, so it doesn't fall back towards the Earth in this ellipse. It stays with Mars. Now, if you notice, Earth and Mars have to have a very specific position, and so there's only like a 2 or 3 week window every 2 years in which this happens. So if NASA wants to go to Mars, they have to launch within this window every 2 years. So how long does a Hohmann transfer take? Well, you can sort of guesstimate how long it takes. You can approximate it by basically saying, like, Earth has a 1-year period, Mars has a 2-year period. If you average those, it's about 1.5 years, which is about 18 months. And then because you're only going half the elliptical orbit, you divide that by 2, and that's roughly 9 months, which is pretty close to the answer. But in reality, you can calculate it using the real equations, which you use the semi-major axis, or SMA. And the semi-major axis is the apogee plus the perigee divided by 2. So the apogee in this case is the Sun-Mars distance. The perigee is the Sun-Earth distance. You divide that by 2 and you get this semi-major axis. And then you use this formula, pi times the square root of the semi-major axis cubed divided by the mu of the sun. And that tells you that it's about an 8-month trip to get to Mars. So in summary, Hohmann transfers allow us to change orbits from one circular orbit to another circular orbit. And you can either go up or you can go down. You can go from Earth to Mars or Mars to Earth or geosynchronous to low Earth orbit or low Earth orbit to geosynchronous. Doesn't matter. You use the same type of technique, this Hohmann transfer. We can apply this to all sorts of orbit transfers, either near Earth or in planetary environments. They all use this Hohmann transfer.